All right, so there's two new projects I want to point you to. And one is here, custom UPX, worth extra credit here, that goes on a cloud machine, works fine on an Ubuntu cloud server. And the other is manual unpacking of compressed files with OllyDbg. And as you can tell, both of them are working on UPX because this year the Flare challenge, Flare on Challenge has got things packed with UPX. So that's what I spent last week struggling with. And this one, by the way, is in fact chapter 18 of your textbook, which I never covered before, but pretty much is just all in that project. So the custom UPX one is really pretty easy, although it took me days to get it working. It turns out that if you want to make your own version of UPX, it is really hard to compile. And I finally found somebody's master's thesis from 2018, or J. Mayank Patel wrote a master's or honors thesis in undergrad or grad school. And as one of his appendices, he tells you how to compile it. And I was able to use that. That got me much closer than any other instructions. So I finally figured out how to do it. So it's pretty easy once you got the right commands. You have to install some special packages on a modern Ubuntu server to compile 32-bit code and run 32-bit code. And then the thing that makes it really annoying is UPX is in like 4 different pieces. And you have to have them all extracted and placed in the right folder with the right name, and then you have to have an environment variable set that specifies and tells it where it is, and it's just a lot of little fiddly pieces to keep straight. So first you get UPX itself from GitHub, and then you get UCL, which is the compression library, and that you have to separately compile and separately store locally. And then you have to make this environment variable, the UCL directory. If you don't, nothing will work. So I put it in the bash RC. So every time you open a bash prompt, it'll automatically load this environment variable. Because one thing that happened to me, and I see it happen to others who got very frustrated, is you get partway through it, then you restart your machine, then nothing works at all because after you restart your machine, it forgot this environment variable. Anyway, then you got to get this LZMA, which is a compression library. And then you got to get something called stub sources, because what UPX does is in fact kind of incredibly amazing. And I did not appreciate how UPX worked so much until I started messing around with it. So let me actually start with a little demo of UPX here. Let's go here. This is the Flare on VM, which has UPX installed along with pretty much everything else you could ever want. So if I go to the downloads folder, and I'll make a new, whoops, well, that'll do. I want to make a new folder called demo, which I guess I got a name down here. Okay, F2 demo. All right. And I've got putty. I'll just use putty. Let's copy that. Same putty we used in a variety of other, not that, copy, on other projects like the OllyDbg projects. So there's a folder called demo with putty in it. Let's go to the command line and cd to downloads demo. Okay, and do a directory. And I see I've got putty in here. So I can do UPX. If you do UPX all alone, it gives you this help message. And you can now compress files. If you do UPX minus output putty, I'll just say puttyc.exe. And then putty.exe. That'll take putty and compress it. And now I'll have a second file called puttyc that is smaller. This was 530K, and now it's 267K. Now, what I had not realized when I looked at this, the compressed one will run. When you run this file, here's the original putty. When you run putty, it opens up this window, so you can connect to a server. Putty compressed does the same thing, of course. That's the point of it. It's for compressing files so they're smaller on the disk and all the strings are concealed. It's kind of like how you make malware. I always thought of them as like unzipping files, where you'd have to unzip it and then run what came unzipped, but that's not what it does. It takes the sections, like the text section and the data section and so on, and it compresses them individually into different sections, and then it decompresses them into memory, creating the running memory. So it has to know what type of executable you're running. So it has a whole bunch of code for every type of executable, for 16-bit Windows code, 32-bit Windows code, 64-bit Windows code. I'm not sure it handles 64, but anyway, it does Linux code and Mac code. And it does like a dozen different formats, and it has different code for each of those functions. So anyway, that's what these stubs are, all these different coverages of all these different types of files. And then, for some reason, which I did not find anywhere in the instructions that came with this, but it was in that guy's thesis, you have to add these commands here to help it start portable executable files. So you have to add these two assembly language commands to this file, which I would never found out the other way. And then you can finally make a custom UPX. So when you first do it, you've got a standard UPX that just works as normal, and that's fine. But while I was doing research for this, I found a fun book. So you can make a compressed version of PuTTY like I just did, and now you can start modifying UPX. So you can just put in a print statement that will print a message. That's a simple way to get started. And then when you compile it, now it'll give you that message. So it shows that you've got it under control. You can now modify UPX. And I found a fun blog that somebody wrote talking about anti-unpacking techniques. And this is quite recent, and he intended it for Internet of Things malware, but he said people use UPX a lot, and here are some common techniques they use to conceal stuff. They rewrite the magic header, which by default is UPX exclamation point. They change the copyright string, which I couldn't find. They change section name headers, adjunct bytes, and so on. So if you use a tool that we've used before, which is PEView, you can see what this does. And I think we even did this in an earlier project. If you go to PEView and you go to my demo and open PuTTY, then I will see that you have a text, RData, data, and resource section. And I don't think I can change, maybe I can change the font. Cool, okay. Let's make this font bigger too then. There we go. So you've got normal sections here, text, data, RData, and resource. If you open PuTTY compressed, then you don't have those. You have UPX0, UPX1, and resource. And if you look at UPX0, it has a size of raw data of 0 and a virtual size that's much bigger of 48,000 in hex. So this is a section that contains no data at all. It's just an empty place to put code. And if you go to UPX1, this is compressed code. This is where all the zipped stuff is. So when you run the program, it unzips all this data and puts it in there and then runs it from there. That's how it works. All right, so let me go back and just point out what goes on here. So now you can create a modified packed file. You can open up a packed file that you made, PuTTY in a hex editor, and you will find UPX. In fact, let me just do it here with the HXD, just to be clear. If you open it with our good old friend HXD, the hex editor, and you open that file, which is downloads, demo, PuTTY-C, here's what it looks like. And let me see if I can make this font bigger. View. Looks like I cannot. Tools. Okay. Anyway, it shows me here the typical thing. This program cannot be run in DOS mode. Then it has the PE header here with PE for portable executable. Here's the MS-DOS boot header, MZ. And down here it has a UPX0 section name and another section name. And much lower, it has the magic thing, UPX exclamation point. That is the magic thing that marks where it has all important information, like the compressed file size and the uncompressed file size and the version and the method of compression. There's about 8 variables determined right after that in this little header area that determine everything. So one of the things that the program absolutely does is it looks for this magic string, and if it finds it, then it's ready to run the file and decompress it. If it doesn't find it, then it has a problem. So if you modify that, it has So if you change that from UPX to UPY and save the file, then what will happen is it will still run. You can still launch it and use it. But if you try to decompress it with UPX, it'll refuse to decompress. So this is very good for malware authors. You make a malware that will run, but the malware analyst can't unpack it to analyze it. And this is commonly done. That's why you do this. So there are various solutions, which we'll talk about, but one solution is to make a custom version of UPX. And there are, in fact, a whole bunch of custom versions of UPX floating around that skip over various errors that would stop the normal UPX. Here we're going to do the simplest thing. You just go in the source code and change the magic word to match the magic word in your file. So change this to UPY by changing 58 to 59, and then you can decompress that file. That is the simplest thing, but of course what would be even cooler would be to make something that can somehow withstand a variety of changes. Anyway, so that's what this one is, and that is one way to overcome damaged, hacked packed malware, where they pack it and then modify it so it's hard to unpack. But the more general technique is the other one, which I put in a different section here, because for this one, you really need to have Flare VM, or at least I recommend it. You probably could install the tools, but this uses some more new tools, and I thought this was very interesting. So what you do, the first is we'll use a couple of tools here that we haven't used before. I'm using the new tools in the Flare VM. So PE Studio is a tool we have not used otherwise in this course, and it is very, very wonderful. So if you go into the Flare folder, into Utilities, you'll find PE Studio. And of course, I don't even bother to do it that way anymore. Once you know something exists, you just click the magnifying glass and type PE, and there's PE Studio. PE Studio kind of takes all the static analysis techniques and runs them all at once for you. So if I open an innocent file like that putty, I made a demo folder and I have a normal putty in there. What this does is it is going all kinds of tests on it, which is going to take a few minutes. And by the way, it takes the hash value and it sends the hash value up to VirusTotal to get the VirusTotal scan, which is a good thing to do. So anyway, I suppose you might be concerned about it violating operational security if you're really analyzing custom malware, perhaps from a real advanced persistent threat actor, but for we who are just learning, it's perfectly fine. So it's going to send it to VirusTotal, and almost everybody finds this clean because this is just putty. One virus engine calls it malicious, but I think they're not making sense. You have the DOS header and the hash values and such. You've got the file header. Here's the optional header, which I'm getting into trying to solve the difficult challenges, but they don't need to pay much attention right now. Here's directories that are used, but the main thing I look at is sections here. And the sections are the classic sections: text, RData, data, resource. You have a hash value of each section, and you have an entropy value of each section. Entropy is a measure of the amount of information in a section. So compressed data has an entropy of 8. All 8 bits are used. Normal data like text has a low entropy, like 2 or 3, because it's really not using all the characters randomly and there's gaps between words. So the data and resource section have entropies of 2.4 and 3.9. The text section is assembly language. And assembly language is almost random. It's got an entropy of 6.6. So that's kind of fun. And here's the entry point goes into the text section, which is what it should do, because the text section contains the machine language instructions, and that's where you should be going. So this is normal. And down here, if you look at imports, this thing imports 312 functions: create, window, register, class, and it imports them from a whole ton of DILs, user 32 and kernel 32, and that's fine. By the way, this thing also looks for suspicious things in your file, and it finds them here. So it found 5 suspicious things. Even a completely harmless thing like putty has some suspicious things. It has strings on a blacklist. It has a URL in it, which refers to like the URL it came from, and they say that's suspicious. It might be a command and control center. So seeing a few suspicious things does not mean it's malware. It just means there are a few things that are on a list. This thing has configuration files which are full of YARA rules that we talked about in the instant response class, just simple patterns, like patterns you could grep against to detect suspicious things. So there's a lot of imports, and here's all the libraries that are used, and you also have the strings right here. So here's all the strings. This program cannot be run in DOS mode and so on. And it marks some of them as suspicious, like port forwarding, and it even gives you the MITRE technique for the type of advanced persistent threat technique that might use that particular function. So it's really very nice. It gives you all kinds of good information about a file. And that was a normal clean file. So now let's look at our compressed file. So it's PE Studio. You have to relaunch it every time you analyze a different file. Now I'm going to analyze PuTTY compressed. So it's going to take a few seconds to run. All right, I think I should have some information now. VirusTotal is still running, but I have the sections. And right away you can see it doesn't have a text section. It's got UPX0, UPX1, and resource. UPX0 has a raw size of 0 and a virtual size of 500 kilobytes. That's what we're saying. This is all going to be zeros. Here's where all the data is. This area has an entropy of 7.9. That's compressed or encrypted data. It's completely random in appearance. This section contains all the data, and the entry point is in this section, which is very strange. It's not the text section, and that's why it's highlighted in red. That's regarded as suspicious and important. And then you have the resource section over here, which is more or less unchanged. And if you go to libraries, there's a small list of libraries. And if you go to imports, there's only 14 functions instead of like 200 or 300. So it's very obviously compressed data. And all you're seeing here is the uncompressor. And if you look at the strings, there's a smaller list of strings, or at least a simpler list of strings. So that's what you see in PE Studio. Now let me go back to here. And all right, so you looked at that. That gives you a story. So now you get the malware samples and analyze them the same way to get a flag. And then here's how you manually unpack something with OllyDbg, which is a time-honored technique and very nice. It just involves a little bit of familiarity with Olly, really. So you run OllyDbg and you run it on that compressed sample. So I go into Downloads, Demo, PuTTY compressed. All right. When it loads a compressed file, Olly is going to warn you that something's wrong here. A statistical test of the module indicates that its code section is compressed, encrypted, or contains large amounts of embedded data. It noticed that that section is weird. You can just say yes or no here. Yes seems to work. Continue analysis. And notice we've started with a push add. This is what this particular compressor always does. Push add pushes all the general purpose registers at once up on the stack. So you can then do something and then have a pop add later. So if you just look at this code, and by the way, I can make this bigger, I think. View, options, appearance, fonts. I think just OEM will do it. All right, let's right click, appearance, fonts all, OEM. Oh, it's already OEM. Let me try to make it bigger. One more try. Options, appearance, fonts, change, bold, bigger. Okay, there we are. Now it's bigger. Okay, so you can read this code, but you don't have to read it too much. You can just page through it kind of quickly. So it does push the address. Then if you just scroll down a bit, it does a bunch of stuff. And you only have to go down a few pages before you hit the end of it. There it is. It's over. And if you look at the end, it is in this funny location. Remember, normal code loads at 400,000, and the text section typically starts at 401,000. If you view the memory map here, you will see that this one, let me make these sections big enough to see. All right, I don't need that. Hex is fine. The owner is important. There's PuTTY. Here's my PuTTY sections. I have one at 400,000, one at 401,000, and there it is. And here's one at 449,000. The one at 401,000, which should be the text section, if I right-click that and dump, you'll see it's pretty much all just zeros. In fact, somehow it dumped the wrong section. Wait a minute. Now I want to go to 401,000, which is here. It shrunk my window. I must have hit the wrong button. There, right-click, dump. There, it's all zeros. Remember, that is the section that contains no data at first. The data is actually here in this section 449 and up for next through 30,000. That is the code that we're looking at. We're up around 480,000. But then here we are jumping back to somewhere else, 455,000, far away from here. So in this little region, we do some work, then we jump somewhere else. So I'm just going to put a breakpoint here with F2, and I'm going to step through some of this code. In fact, what I'm going to do is I'm going to dump the section that's all full of zeros down here so we can see it. So let me readjust my window to make this visible. Okay, and here I'm going to go to expression and put 401,000. Okay, now we can see it. And now I'm going to single step through this code a bit. So I'm going to go up to, I'll just do F7. F7 will go to the next step. There we are. So now I'm stepping through the code. So it does stuff, and it does more stuff. Then I just hold this down. See what it's doing? It's filling this in. This is the decompressor. It's taking that code that's all compressed and unpacking it into this other section that was all full of zeros and building the program. So this is going to take forever, one step at a time. So I'll hit F9 to just run to the breakpoint. That runs it all. And now it's all unzipped here. And now I'm going to take one jump to jump into the real code here, which is F7. And now I'm at a push 60. And notice what's going on here. To compare this, let's open the normal program in OllyDbg. Olly, if you open putty, not the compressed putty, in Olly, just to see it, that is here. Okay, and let me make the font bigger. View its appearance, font all, OEM fixed, and then it is options, appearance, fonts, change to something bigger. Nope, options, appearance, fonts. Nope, one more time and then I'm going to give up. Appearance, fonts all. Well, let's try Lucida. All right. Oh my goodness, I'm getting. All right. I'll get back to what I had. I think I'm. All right. Fonts, appearance, fonts all. I guess OEM is the best I can do. Anyway, I just made it big over there, but I can't remember how to do it again. The point is, this is the natural putty that is not compressed. It starts with push 60 and then push and then call. And that's what you see here. Notice that it starts being wrong around here, but the code is right. 8BC7 is really right, BC7. What's going on here is Olly is confused. This section was full of nothing but zeros. It ran a bunch of code and filled this in byte by byte. So Olly thinks this is a data section, not a code section. So it's not disassembling it, it's just presenting it as binary data. Let's see, what's the biggest red flag? Virtual size, large entropy. Well, you know, I don't know if, I mean, they're all clues. That's anyway, so now this thing is really ready to run the real program. So what's happened is I now have the program I need in RAM. So what I would like to do is dump it from RAM back to the disk in an uncompressed form. And you can do that with this plugin called OllyDump. First, you have to find the real starting point of the decompressed code, which I did. For UPX, it's very easy. You can just scroll down and see it ends, and there's a big jump. And you follow that big jump, and you're there at the real starting point. So you can dump it right from here. Plug in OllyDump, dump debug to process. And you always have to make sure that this address is correct because sometimes it's not. This one is 400,000 with offset of 550F0, and that's correct. So I can just dump it. It's going to rebuild the import table, but it doesn't really need to here. Anyway, I can dump it, and this is going to be putty dumped.exe. So now I have a new executable that has been dumped out. And if I look at this one in PE Studio again, it's going to resemble the original, although it's not perfect. And in my experience, it won't run. But you can analyze it, and you can find the strings and most of the imports, and you can run it in IDA Pro. So you can do a lot of analysis on it. And if you get good at fixing the broken import table, I think you can do more with it. So because you'll see it doesn't bring back all the functions. There were like, I think 312 or something like that in the original one, but this only brings back 280 of them or something like that. So it's still running. Yes, well, I should be able to see the sections in. Yeah, here's the sections. Now I've got UPX0 and UPX1, resource and resource, and notice the entropy is 6, 5.9, 4, and 5. None of these are compressed anymore. It has unpacked UPX1 into UPX0 and created a normal code section with an entropy of 6.6. The entry point is here, though, still in that section, but at least it's the code we need is there. And here are the imports. Yeah, now you have 277 imports instead of 312. So it got a lot of them, but it was not perfect. And there are some tools to fix a broken import table. I've been spending the last couple of days trying to get them working, and I haven't got that working yet. Hopefully by next week, I'll have some projects where you can practice fixing broken import tables. But anyway, that's what I wanted to show you. This is the process called manually unpacking packed code. If you can run it, then you can get the copy out of RAM and make a disk file, but it's not an incredibly simple process. But this is the standard way to do it in OllyDbg. In the simplest case, that works. When it fails, there are a whole lot of advanced tricks to compensate for its failures. Now let's see about questions. Yeah, so I mean, I'm not quite sure how to rate those flags, but large entropy above like 6.7 is almost always compressed or encrypted. How is this different than self-modifying code? It is self-modifying code, isn't it? But it's not what it did. It did not modify the code section. It's a very good point. This did not decompress into the code section. It had another section that was empty, and it decompressed and wrote over there. And by the way, self-modifying code is not disallowed by the OS. You can do it. It's just not a good practice. The rules are that you should never do it, but you can create a section and allow read, write, and execute on it, and Windows will allow you to do that. But no legitimate code should ever do that. So you'd see it as things like a red flag and these red flag indicators. And one thing that's really crazy is the 32-bit Raspberry Pi always makes every section read, write, execute, which is a major security flaw. But yeah, good. These are very good questions. Are there any more questions? Let me just check the project. I think there was a couple more things to point out here, but pretty obvious. So you go through that, and there's a couple flags you find on the way of doing that thing with putty. And then I got some challenges. I made a variety of these things. So go to Lab 1801. Like say, chapter 18 of your textbook covers this technique. So we can do their sample and get a flag there. And here I made my own code with using the same technique as that project where you make a keylogger. So I made my own code in Visual Basic or in C++, compile it with a Microsoft compiler, compressed it with UPX, and modified it. And then broke it so you can't decompress it. And again, you've got a password guessing game that you have to unpack to see the strings. So how can they provide such good security tools for free? Oh, Microsoft? I mean, I don't know. That's a very good question. There's tons of free security tools. I think the point is, in fact, there's not a lot of market for these hacking tools until recently. And there's a lot of, people that just have the Linux aesthetic, I think. As I think I found out as I started a corporation and stuff, Making a real professional tool is a lot about marketing and polishing, and there's a lot of work in that. So your typical, security hacker that just writes something and puts it on GitHub is now bored with it. And there's a ton more work to make a real commercial product, and especially to support the product and handle all the complaints that come in. So, I certainly understand how you dump something out there for free instead of having, it's a whole different job to maintain it. Anyway, so that's a step forward, and I encourage you to check out those projects. I'm going to stop this video, but I'll stick around.